All right, you're taking your constructed response portion of your final tomorrow. So consider making a note card, could be kind of your cheat sheet. Really use the review. I looked at the test and it's literally the same, just with different numbers. So we'll go over any questions you still have on them now. Just a reminder, I do post all sorts of resources in Schoology. Yesterday, I recorded all my classes of us going over the final exam review. So if your question didn't get answered and it still doesn't get answered today, I might have answered it in one of my other class periods. And then of course I'm recording right now, and that'll be in there. And also, so we're testing tomorrow the constructed response portion, but the other reviews for the one you take on final exam day are in here. If you go to this week's folder, the blue puzzle piece is for a grade, and then the green one's extra credit. So the blue puzzle piece, like tomorrow, once you turn in your constructed response test, you'll get the paper review for that. It'll match that. So you could do the work on the paper and then put your answers in Schoology. And then the green one has different numbers. And it'll probably be different numbers every time you attempt it, because there's like 10 different questions possible for each question, if that makes sense. So if you really want to see, like, if you're understanding it, if you're getting it right, then you could use that green one to like really help you. I know for some of you, that's like the boat you're in. It's either if you pass the final or you don't pass the class, for some of you. For others of you, it's just like the difference between the next letter grade up. So that's in there. You can start, well, we will start in class having time for that after you take tomorrow's final exam. Okay, so what questions do we, oh, real quick too. This is in here. The review that we went over yesterday, fully filled out with all the answers and work shown. But of course, like if you copy it and upload it to Schoology for those 20 homework points, it will not help your grade as much as if you like truly try to understand it. So if you still have questions, that's what this time is for. If you're like, I have no clue why that answer is 1,000, or I have no clue how you got 102 here, or something like that, then, we can talk about that, or you can ask questions, something. But it is all in there too. So what questions do we still have on either portion? Could be the one from today, could be the one from yesterday. Kaden? Okay, so the one you picked up today, the second choice on that one. So unit 3 will be completely optional. The other ones you have to do a minimum of 1 per unit, but I'm telling you, do all of it, attempt them all, even if you have to guess. That way I can probably give you some extra credit. But yeah, so this one. It says which of these, we'll probably have to do the whole thing, it's probably all together. But it says which of these scatter plots shows data that would be best modeled with a linear function. So when they say linear, they're talking about what type of equation? Y equals mx plus b. All right, so straight lines, in other words. Which one do you think would be best to model with a linear? The second one. Now, just answering that would give you some point, but then explaining would get you the full point. So what would your explanation be? Okay, it is the most, you could say straight, you could say linear, you could say appears to be decreasing at constant rate. Because in y equals mx plus b, that slope would be a constant rate, like either increasing or decreasing by a constant rate. So something that justifies it. I would say the first one, You probably still could do a linear model, but the data isn't as close together. So that linear model would be not as close to the actual values. The third one looks more like what type of function, if you can remember? It looks a bit more exponential. Might not be, but just strange. Out of the three, the middle one looks the most linear. So then this part. 10 students in a graduate program were randomly selected. The following data represents their GPAs at the beginning of the year versus their GPAs at the end of the year. So these are your actual data right here. Actual, and then plotted, here's my actual. This A, B, C, and D go with this next part. Because you can only have one line. Can't have like a bunch of lines that represent your data. So it says which of these lines most likely is the line of best fit for the data provided. So first you would need to draw a line of best fit through the middle of your data as straight as you can. So I would say like use one of your papers, line it up to where you can see like the middle of your data like that, and then draw your straight line. All right, or if you want to, you could use Desmos if you remember how to do that. Because you do have a table with the exact values for each coordinate, so you could copy that table into Desmos and have it estimate the line of fit for you. All right, but the other way is to draw a line through the middle of your data, straight as you can, and then find two coordinates from that line to estimate your slope. So does it matter that they are actual data points? No. No, in fact, I think the way I drew my line, I'm not touching any of them. I'm just putting a line in the middle where most of the data is clustered around. So based on where I drew it, what could be a coordinate that we could use? Well, it's hard to see, you might have to like. 3.6, 3.5. Did you say on your paper?
Yeah.
Where you do the line? Okay, we can do that. But again, I don't have it on like a desk in front of me, so this might probably be a little bit better drawn. So that could be one of the coordinates. What's another one? That appears to be on the line you drew versus off the line. 3.8 and 4. So here-ish. Okay.
The second one is 3.8. The first one.
You said 3.8?
Yeah.
Okay. Okay. So those are our two coordinates that appear to be on the line. Pick one of them to be x1, y1, the other one to be x1, y, or x2, y2, and then what do you do? What did you say, Lauren? Okay, how do you know this is track? So you're plugging it into y2 minus y1 over x2 minus x1. So this would be a formula that I probably put on my note card. I didn't see anyone get up to go get a note card, so use that advantage or wrong. But yeah, so y2 minus y1 over x2 minus x1. So the way that I labeled it, it's 4 minus 3.8 over 3.8 minus 3.6. What's 4 minus 3.8? 0.2. What's 3.8 minus 3.6? 0.2. Divide them, we get. So then looking at my answer options, which of these is closest to 1? B. And potentially B. So we also want to check the y-intercept too. So A and C are definitely not it because the slope is too far off. And also note that they kind of wrote it in reverse. They wrote the y-intercept first and the slope second. Slope is always in front of the x. The question on that so far. Okay. Now, based on where my line is drawn, it looks like my y-intercept is somewhere around here. Granted, we could solve for it algebraically because we really couldn't assume, but it's somewhere around here. Does my y-intercept look closest to about 2.5 or 5.8? I think 2.5 might be a little bit more reasonable. 5.8 would be like way more up on the ground.
Ms. Medina.
You could say, I estimated the slope be approximately 1. And the y-intercept, we didn't solve for it algebraically, we could, but, and the y-intercept would be approximately, I don't know, 3.3. Option B is closest. Because when you're estimating by hand, you probably will not get the exact answer as one of those ones, but you'll get close. Gavin? So there's that. Also, real quick, you can confirm your answer with Desmos. You don't need Desmos necessarily for this, but you can confirm if there's like 2 options that are really close. But if you're explaining, don't just say I put in Desmos. Okay, you could say I did this in Desmos, like I made a table, da 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 da. But you can't just say I put in Desmos and expect to get like full points. All right, but 3.5, 3.6, you're basically just copying the data table. 3.8, 3.7, 3.6, 3.9, and you guys would actually do the whole thing. I'm only going to do some, which of course might affect my stuff, but it is what it is. All right, so you can see my dots there. Do you guys remember what you would type into another cell to make a trend line? Y1, squiggly, M, then what? Because what equation do straight lines always have? So you're basically doing that, except you're putting Y1 and X1 because then you can attach it to this table. Does that make sense? So Y1, squiggly, M, X1 plus B, like that. Draws a line through the middle of your data, and then it estimates this stuff for you. I didn't put in all my data, so I'm not gonna like, you know, whatever, but if I did, then I could really find which answer is closest. Every time I add in a new data point, the trend line changes a bit. So you would need all your data in there. Questions on that process? Okay. So what other questions do we have on either parts, yesterday or today's, Anthony? The first one on unit 7. Okay, so for unit 7, I would argue that the first one might be the hardest for students. But really, if you just follow the steps to a T for completing the square, maybe copy them onto your note card that you can make for tomorrow, then I think you can get it right. So it says the solutions to this equation are 1, 6, and 5, 6. Show how to find these solutions by completing the square. So if you completely don't make a note card, completely forget how to complete the square, if you can show it to me another way, I'll give you like half credit. But completing the square, showing that work will give you full credit. So here's those steps for completing the square. So, and these are copied directly from your notes. So if you're like, those are weird, feel free to rewatch lesson 12, where we explain why those are those steps. But the first step, it wants the C to be on the other side. So for completing the square, it's the only one that doesn't want it in standard form because it's 0. So what's my C in this? No. 5/36. How do I move it to the other side? And whatever you do on one side of the equal sign. Okay, great. So then that cancels out. X squared minus x equals -5/36. If you can at least give me that part, I can give you some of the points. All right, so that's why I'm telling you, attempt them all. You have an hour, that's way more than enough time. Anyway, so yeah, that's step 1. Step 2, what is this doing? Go read that to me. We're taking 1/2 of b, then squaring it. So what is my b in this one? And what is half of -1? Good, you could do -0.5. I'm just gonna leave it as a fraction because we have fractions in this problem. So yeah, -1/2. And then we're squaring it. What does that become? All of these, by the way, you could do in your calculator. You don't have to avoid the fractions if you don't like them. But we have, anytime you do a fraction, put it in parentheses like that. And we're squaring it. If you want the fraction of it, press this button. And you get the simplified fraction. So -1/2 squared is 1/4. Questions on that? All right, so we took half of b, we squared it. Now we're gonna add it to both sides. So we're adding the what to both sides? The 1/4. So on the left side, that makes a perfect square trinomial. We'll factor that in the next step. On the right side, I would probably recommend using your calculator. I don't even want to do that one right now. So -5/36 in parentheses plus 1/4. Also, about this. Okay. So then press the fraction to decimal button. You get 1/9 for that. So that's what the right side is not. The left side, we made it a perfect square trinomial. That's what completing the square even means. On the right side, we get 1/9 because we have to simplify. Questions? All right, so then step 3 is to factor the trinomial. So how do you factor trinomials? Diamond method. So a times c on the top, so 1/4 on the top, b on the bottom. Now, if you're like, wow, that seems annoying. What I've noticed for completing the square, once you factor a perfect square, it always ends up being whatever half of b was. What was half of b? It was -1/2. So see if that makes it work. Right, does that multiply to 1/4 but add to -1? So then that's my 2 factors. The whole point of that, they should be the same, is so that I can write it as a perfect square like this versus having like 2 separate factors. So then there's that, still equal to the 1/9. And the last part is to solve for x. So isolate it. Start with what's farther. Would that be the 1/2 or the 2? So how do you cancel a square? Whatever you do on one side. Okay, good. On the left, it's now just x minus 1/2. You can even use your calculator for the square root of 1/9, but I'm gonna tell you now. It's plus or minus 1/3. So don't forget the plus or minus, because that's how you get the 2 answers. All right, x is still not alone. What's opposite of minus and 1/2? And whatever you do on one side. All right, and it did tell you at the beginning of the problem what the 2 answers would be. And so it's gonna be when you do the positive 1/3 plus 1/2. I think that's 1. What was it? 1/6. I don't remember, I'll have to check. And then 5/6 for the other answer. The other answer you get from negative 1/3 plus 1/2, and I would just use my calculator for that. I probably have it backwards, but it doesn't matter. So 1/3 in parentheses plus 1/2, like that. Decimal, but then make it a fraction. It is 5/6, so I know I did it right. And then the negative 1/3, if it's plus or minus, will be 2. Plus 1/2. Is the 1/6. So you don't have to avoid fractions. The calculator can do them for you. You just have to know how to type it in the calculator. So good there? Yeah, don't just get that one. I know probably a lot of people will, but attempt it. I think you guys can do it, especially if you make a note card. Questions on others? Hayden? The first one from Unit 5. The first one from Unit 5. All right, so that one. Can someone remind me what Unit 5 was about? What'd you say? Exponential functions. And I do also have it written up here, so. If you don't have that equation memorized, write it on a note card, make sure you bring that note card. But, yeah, so it's a times b to the x power. What does a stand for? Okay, maybe we'll come back to that. So number 1 on Unit 5 says a car that was originally sold for 18,000 loses a fifth of its value each year after it was bought. After 4 years, how much is the car worth? And then write an equation for the value of the car, not the phone, years after it was released. So I would start with number 2 because I feel like you need the equation in order to answer number 1. So I would start there. And you use this setup. So what's my A going to be for this problem? 18,000. So A stands for initial amount. Whatever amount it was when you first started measuring, whatever the problem says when you first bought it. So far it's 18,000. And I think it wants it in function notation. So we'll do C for car of T, because time is always an input. All right, that 18,000, do you guys remember what B stands for? Or do you know what the B will be for this problem? Forfeit. Now, you might be wondering, some of you, where are they getting forfeit from? Like the problem says 1/5. Why am I not multiplying by 1/5? Well, if you multiply by 1/5, then you have to go back and subtract it from the 18,000, and you have to do that for every single year. But if you multiply it by what it's keeping of its value, so if it's losing 1/5, how much of it is it keeping? Forfeit. So if you have 5 pizzas or 5 slices of the pizza, take one away, It's still a 4, right? So if I just do that instead, because the equation needs it to be multiplied by b, then I can actually get that easier, like in one step versus multiplying by 1/5 and subtracting each time. All right, and then it'll be to the t power. So now I can plug in any number for t and do that instead of like trying to keep the pattern going. Okay, so yeah. If I want to solve for 4 years after it was bought, what would I do with the 4? Put it where t is. Put it where the t is. And I'm using function notation, so the left is just telling me I plugged it into this. On the right, you're plugging in 4, and I would just put that all in the calculator, at least just the right side in the calculator. I don't really see how you could do that by hand otherwise. Sorry. Okay, so 18,000 parentheses 4/5. Very important, the parentheses, all to the 4th power. If you are getting something other than $7,372.80, then let me know so I can help you before tomorrow. But if it's the problem about money, make sure your answer looks like money. So it should be $7,372 point what? 0.8. All right, just put that 0 in there to make it look nice. Okay, questions on that one? I have time for one more, unless you email me and ask me your questions later. So what one do you want to see this one on? The real thing, yes? The second one on this one? Okay, so also about exponential function. Same equation setup. So a times b to the x. So that represents the population of fish in surprise years since 2014. So when the fish population in the lake was first surveyed. So what's in the A position, my initial amount position? The 1,000, and even if they have it reversed, A is always the single number, not the one with the decimal. So then what was the population in 2014? Well, that's when we started measuring. So it should be the 1,000. So it's in the A spot. For this model, what does it mean when t equals -3? Right? Time can't be negative, can it? So what it means is 3 years before 2014. So what year? The 2011. So yeah. Usually they specify what the time is, whether it's years, months, days. This one it's years since 2014. Negative, it must be before. And then it says for t equals -3, is the fish population more or less than 1,000? Less. And you can probably do that without even calculating, but you could also just plug it in and see. Is it more or less than 1,000? It'll definitely be less. But this one we said, since it's multiplying by 3 for after 2014, well then before 2014 it would be divided. Is another explanation. There's more than one way to explain it. Questions on that? Okay. If you have any other questions that you want to ask, let me know. There's still a few minutes, but I don't want to like talk over your time.